Okay, but let's get into our algebra. So our very first question, nice and straightforward, nothing too complicated going on in example 1. And the reason I've started with this is because this is one of those questions that we will generally ask because it's a way to test your understanding of terminology. And it's a question where you should be getting the marks. These are a nice, easy, I mean, in this case, 1, 2, 3, 5 or 6 marks, a nice, easy 5 or 6 marks that you can get in your algebra section. If you think of 5 or 6 marks in like the context of a 50-mark test, 5 marks is 10%. If you can answer these 4 questions, you have got 10% already, and that's sorted. Obviously, we still need more because we don't just want 10%, but it's an easy 5 or 6 marks that you can get in an assessment. All right. So if we have a look, it says example 1, consider the following expression, and we have been given the expression as follows. So we have got minus 6p cubed plus 3 minus q plus the fraction p minus r squared over 2. That's what we've got. And what we need to remember is that this is now going to be used to answer all of these questions below. So I need to keep referring back to this expression to help me answer the question. So we're going to do these quickly on the chat together. So my first question to you, and I want your answers on the chat. How many terms are there in this expression? So in the chat, I want to see your answers. How many terms do I have in this expression? Good, guys. Well done. Okay, so remember, plus and minus signs separate my term. We don't really care or don't need to consider this first sign because it's attached to that 6p cubed term. So these plus minus plus are separating my terms. So here's term 1, term 2, term 3, and term 4. So exactly, we have got 4 terms. Someone put on the chat there, and I can't remember who it was now. This is what we call a polynomial. It is a term, yes, it is an expression with several terms in it. Remember, monomial, 1 term, binomial, 2 terms, trinomial, 3 terms, anything more than 3, so 4 or more, we call it a polynomial. Right, again, quickly on the chat, what is the coefficient of Q? So obviously it's important to know what a coefficient is. What is the coefficient of Q? And I want you to be very careful. Make sure you are including the correct sign. Giving it away here. Also, it probably was in the quiz because we did this a while ago. So this is like from the beginning of this course. Okay, we've got some mixed answers here. So first term is this minus 6p cubed. Second term is the 3. Completely separate is this minus q. So when we go and have a look at the coefficient of q, firstly, a coefficient is the number in front of the variable. It's the number that we are multiplying the variable by. And so if we go up to our expression and we look at the number in front of q, we see that we have got a negative 1 in front of q. And so our coefficient is negative 1. That is what we are multiplying the q variable by in this expression. So be very careful. That 3 is a completely separate term. It's got nothing to do with the q term. The negative 6 attaches or is the coefficient to p cubed. I asked you for q. So we only look at the term that has q in it. Alrighty, so that's our coefficient question. Question C is asking what is the constant term of this expression. So in the chat, what is the constant term? And again, you obviously need to know what a constant is. I will let you have a chance to screenshot when we are done, but you're welcome to screenshot as we go along, yes, but I will give you a few seconds once we finish with this example to screenshot. Very nice, guys. Well done. Okay, so let's just define constant in case some of us are confused. Remember, constant is a term with no variable in it. It's a number by itself. Okay, so if we go to our expression, we want to look for the term that only has a number in it. We can see that's term 2. And so our constant term is 3. That is the term that has no variable attached to it. Very nice, guys. Well done. Right, so question D is now telling us to determine the value of our fourth term, which is p minus r squared, all divided by 2. But now, very importantly, I'm giving you values for r and p. So I am telling you very specifically, whoopsie daisies, that r is equal to -3 and that p is equal to +1. So what that means is I need to take these values and I need to substitute them into my expression in order to find the value. So I want to take this value for p and replace p with its value. And I want to take the value r and replace r with that value. So I want you to try. We're using substitution. Give it a try. Let's see what you come up with. Remember to apply BODMAS, guys. You need to apply your order of operations here. Keep those answers coming in the chat. We're getting a bit of a mixed bag, which is fine, but let's keep it going. Remember, your expression is p minus r squared divided by 2. Okay, remember your substitution. My suggestion, when you are substituting, use brackets because it just reminds us of what operation needs to occur in order for us to find our answer. I'm sort of liking what I'm seeing so far. The only thing I'm going to say is double check your signs. I'll give you 30 seconds and then we're going to have a look. Alrighty, so I'm going to do this one. Don't know why I chose to use those words, but anyways. Right, so here's our expression. I'm just going to write it a bit bigger for us. P minus r squared over 2. So we're going to substitute. P is 1, so I substitute 1. And I'm just using brackets again because remember, we need to bear in mind what the operation is. Minus. Now I'm substituting the r value of -3. That is being squared. And everything is then being divided by 2. Now, what's really important here is that you remember that -3 squared is -3 times -3. A negative times a negative is a positive. 3 times 3 is 9. So what you actually have in your numerator is 1 minus 9 divided by 2. Now we can simplify that. 1 minus 9 is -8 divided by 2. And that simplifies to -4. So that's why I was saying double check your signs there. When we go and substitute and when we go and simplify, we end up with an answer of -4. Now, guys, we would tell you to do this without a calculator, but you can go and double check this on a calculator. I don't have my calculator with me, but I've got a scientific one on my phone. So let's just show you what it would look like. If you go and double check yourself on a calculator, obviously, again, use your brackets to make sure that you are substituting in everything correctly. But if I go and substitute in, let's see if this is gonna, there's the fraction, exactly as what I wrote down. There's my answer. So use your calculator, double check. I substituted in, I got my answer. Yes, you need to show you're working out in a situation like this when we tell you no calculator. And yes, we've told you no calculator. This is why you show you're working out. But use your calculator to double check yourself. Like I say, like I was marking exams today where, yes, it said no calculator, but like, just make sure. Don't lose silly marks for no and unnecessary reasons. Okay, so like I said, this first example is one where we are testing that you understand the terminology. So you understand what terms are, constant term, coefficients, etc., etc., and that you are able to substitute in values and work with that operation or that order of work without a calculator. Yes, you want to check, but you need to be able to show all of your working out. Right, so those of you who wanted to take screenshots, there are all 4 of those questions all on one screen. You can take a screenshot now. I'm hoping no one has questions, but if you do have questions, now's the time to raise your hand. Otherwise, we're going to have a look at example 2. Omva?
No.
Yes.
What happened to that square? It's the second
Okay,
method.
so what I did with the squared was I expanded essentially. So I said that I know that -3 squared is -3 times -3. So I just expanded the exponent to do the multiplication, and then I took my answer and put it in my next step. Does that make sense?
Yes.
Okay, good. Alrighty, guys, let's have a look at example 2. So again, this is one we like to ask you to make sure that you're understanding the language around expressions. Just gonna hide that one. And in this first one, it's telling us to add the following expressions. Now, hopefully we all know what operation add means, but just as a reminder, add means addition. So we are plussing these terms. So I want to take this whole first term, add it to the whole second term, or rather expression, and add it to the whole third expression. So I want to set up an expression where I can add all of these together. So let's do that. We've got 5x squared. I'm just going to keep the brackets for now to remind myself that I'm adding these expressions together and which expressions are which. So 5x squared minus 3x cubed plus 2x plus the second expression, which was x minus x squared, plus the third expression, which was 2x cubed minus 5 minus 4x squared. So I'm adding all of them. That's what I was told to do. Now, guys, what we need to remember is that when we've got a sign, whether it's plus or minus in front of a bracket, we need to remember that technically this means that there's a +1 in front of these 2 brackets. And technically that means that I need to take those +1s and I need to distribute them into my brackets. But what I also need to remember is that if I times anything by +1, it makes no difference. So 7 times +1 is 7. -2 times +1 is -2. -3x squared times +1 is -3x squared. So that coefficient to the bracket of +1 doesn't change anything. And so from this point, if we wanted to, we could actually just drop all of these brackets and just deal with the terms from each expression. Lots of terms, but it's all right. So what we have here is all of our terms being added together from these 3 expressions that we now need to go and simplify further. So this is what I want you guys to do. I want you to go and simplify this expression. And the only hint I'm going to give you is like terms. That's it. So I want you to try and simplify this for me. I'm going to make this a little bit bigger. Simplify the expression 5x squared minus 3x cubed plus 2x plus x minus x squared plus 2x cubed minus 5 minus 4x squared. and my hint, like terms. Remember to put your answers on the chat. Remember, guys, as Yolanda always tells you, you need to write it down first before you put it in the chat. It also means that you can then mark your work once I do the answer. Teto's fast and furious tonight. Well done. Keep them coming. Oh, guys. I'm hoping this is furious working going on. I like to see the faces of concentration. Well done. Lita looks very excited for maths. As you all should be. Maths is the best. Okay, I'm the only one talking right now, so as long as you can hear me. I agree, Senzo. Teto is Fast and the Furious every day. Not a bad thing, Teto. But the rest of you, you also don't have to be Fast and the Furious every day. Best believe I have slow and steady like a snail very often. Alrighty, grade 8. Would anyone like to raise their hand to explain it to us? Teto, I knew it was going to be you.
Hello, ma'am. Can you hear me?
Hi. Yeah.
Ma'am, so when you simplify it with the like terms, it ends up being 5x squared minus x squared minus 4x squared. And then, well, usually what I do is I put them in different lines, each different thing, instead of saying plus. And then at the end, I just plus them together. So in the second line, I had negative 3 cubed plus 2x cubed, negative 3x cubed, sorry. And then in the last one, it's 2x plus x. And at the very bottom, there's also just negative 5 because there's no like terms. So the answers ended up being, for the first one with cubed, it ended up being 0 because 5x squared minus x squared is 4x, yeah, 4x squared. And then minus 4x squared is 0.
Good. So these actually all cancel, like Teto said. Yeah, keep going.
So then with the next one, it was negative x cubed or negative 1x cubed.
Okay. Can you explain why?
Ma'am, because since it's in the negative and you're trying to add positives, you slowly get closer towards like the 0 that points in the middle. Good. So basically 3 minus 2. So 3 minus 2 is 1. So it ended up being negative x cubed.
Good.
Then with the last one, you had to calculate. It was 2x plus x, which is just 3x.
Excellent.
And then there's the negative 5 at the very bottom. So you can't really do anything else from there since there isn't any more like terms. So the
Right.
answer would be negative 1x cubed plus 3x minus 5.
Perfect. Well done. Okay, guys, and very important there, like Teto said at the end, there are no more like terms, so you can't do anything else. Once you have run out of like terms, that is it. You are done. Right, so our like terms there, I've underlined them in different colors. I've also then grouped them in the next step. So all of your x squared terms, which I underlined in red, are here. And this is where Teto said they're cancelled out because you subtracted them away. Then we had the x cubed terms, which I had underlined initially in green. Then we had our x terms, which I had underlined in blue. And then we had our constant term, which I had underlined in the black squiggly line. All right, so collect your like terms, add and subtract your like terms. And like I say, once you have no more like terms, you are done. You can't do anything else. Right, very nice. I'm going to wait here in case anyone wants to screenshot. If you've got any questions, you can raise your hand. Otherwise, we're going to have a look at another one. Okay. Right, guys, let's have a look. So question B here is now a subtraction example. So it says, from the expression 2a minus 3b minus 4c, subtract minus 2a plus 3c minus d. So this is a lot of words, but we actually need to understand what this is saying to us because it's no good rushing into something that we don't actually understand what we're doing. So if I had phrased this as from 10, subtract, I don't know, 2, hopefully we know that this expression would then be 10 minus 2. I'm taking 2 from the 10. So if we apply that same logic to what's happening here, we need to subtract this second expression from the first expression. So we need to say 2a plus 3b minus 4c minus my second expression of minus 2a plus 3c minus d. I am subtracting the squiggly one from the first expression. Now again, once I know what I'm dealing with, I can now start to simplify. Unlike this question A, guys, so remember I said here, we could see that in front of our brackets, we had positive ones. This is a bit different because I'm subtracting. What I now see I have in front of this bracket is a negative 1 coefficient. And that does need to be distributed into my bracket. Unlike a positive one, when I multiply by a negative, I know that I'm going to have sign changes. So I can't just ignore it. I have to do this distribution. All right, so if we go and distribute, we've got 2a plus 3b minus 4c. I can basically drop that first bracket because I don't have anything to distribute. But now in my second term, I need to multiply. Negative 1 times negative 2a is positive 2a. Negative 1 times positive 3c is negative 3c. And negative 1 times negative d is positive d. Now that I've done my distribution, now I can find my like terms. So I've got the a terms. I've got my b term. There's only one of them, which is not the end of the world. My c terms. And then my d terms. My d terms, again, I also only have one of them. Again, grade 8s, if you need to group them together so that you can see exactly what you're adding and subtracting, that's obviously absolutely fine. You don't have to, but you are welcome to. And now we add and subtract our like terms. So 2a plus 2a is 4a, plus the 3b, doesn't have any like terms, so that's all I can do with it. Minus 4c minus 3c gives me a negative 7c plus d. I can't do anything more with d because there's no like terms to it. And that's it. There's no more like terms. All of those terms have a different variable a, b, c, and d. So I can't add or subtract them. And so what I end up with is my simplified expression of 4a plus 3b minus 7c plus d. So it is very important when you start subtracting expressions that you remember to distribute the negative 1. I'm actually going to write that as a note because even in like matric, this is where people go wrong. Silly mistake, and you know better, but it's very important. So when we subtract expressions, it's a weird looking way, but we're going to roll with it. Expressions, remember to distribute the negative 1. Oh, golly, Miss Molly. Okay. You distribute the negative. Right, guys, that is very, very important. And like I say, this is one where grade 10s, 11s, and 12s still get wrong. It's not because they don't know, and it's not because you don't know. It's because we try and rush things, essentially. And because as things get harder, sometimes we start to forget the basics. So we need to remember these basics so that we don't make really silly mistakes later on. All right. So, yes, Teto, exactly. We need to be careful with distribution. Guys, like I say, like, honestly, this is where a lot of kids, especially as you go high into math, go wrong with algebra. It's silly, silly things like distributing a negative. Can't tell you how many times I have to circle a negative and be like, why didn't you distribute? So this you need to remember. All right, take your screenshots. Raise your hands if you have any questions. We're not going to have a full-on brain break, but I'm going to give you like 2 minutes to have a stretch, live your life. Meatle, I forgot the 1. I'm not sure which one you mean. If it's this one that you're talking about, remember I distributed that into my bracket. So I'm not going to have a 1 anymore. I'm actually multiplying it into my bracket. If it's not and you mean the 1 in front of the D, you can write it. You don't have to. That's completely up to you. Right, guys, so like I say, we're not going to have a full brain break just because we've got things to get through. But I'm going to give you 2 minutes to have a stretch, touch your toes, and then we're going to move on. Like Luna Fefe said there, guys, distribution definitely gets harder when we have lots of expressions. And this is why I always say to you, write everything out and don't rush it. If you need to take more paper because you need to write out your answer step by step, rather do that. Okay, we don't want to make a very silly mistake when working with expressions. Umfa, when there's a sign in between the brackets, is it supposed to be okay? So whether it is a negative 1 or positive 1 will depend on the sign in between the brackets. So if we go to the first example, the sign in between all of my brackets was a plus, which meant that I had a +1 in front of them. However, when we get to question B, the sign in front of my bracket was negative. So I then had a -1. So if it's a plus sign in front of your bracket, it's +1. If it's a minus sign, it's a -1. So it very much depends on the sign in between your brackets. Lubanzi, D is not considered 1, but you could write it as 1D. Remember, there's that invisible 1 in front of any variable. So you could write it as 1D, but you don't have to. Adona, we're not subtracting 1 with the numbers in the brackets. We are multiplying by 1. So remember, this -1 in front of my bracket is actually saying -1 times the bracket. So we are distributing, or we are multiplying it to each of these terms inside my bracket. I'm not subtracting it. I'm multiplying because that's what the operation between the -1 and the bracket is telling me to do. Okay, good questions, grade 8s. We're getting the hang of it. Well done. Right, I hope you've all had a stretch. You're ready. You're excited for some algebra. Alrighty, guys. So what I want you to try all by yourselves, because you can do it, is this first example. So I want you to simplify. I'm not giving you any hints. I'm not going to say anything. I want you to simplify. Answers on the chat, and we'll have a look in a minute or two. Okay, so you are simplifying this example. 5x cubed plus 3x squared minus 8x squared minus 2x cubed plus 7x minus 6x. Oh. Okay, make sure we're focused, make sure we're writing this down so that when we do the answer, you can correct. And I'm waiting to see answers in the chat. That is the next thing I want to see in the chat. So let's be focused.
There we go, guys. Let's go. Let's go. Let's go. Put those answers down. Is there anyone writing tomorrow that wants us to help so that you can raise your hand and you can answer this question? We're giving priority if you are writing tomorrow. Okay, Chantal is like, I am here, ma'am. When it's time, Chantal, Ma'am Samantha will let us know so that you can take us through the whole thing.
I just decided to eat some press stick for whatever reason in my life.
Oh, where is who was I talking to? Where's your hand? Now I don't see your hand anymore.
There we go.
Oh, there we go, Chantal. You
Okay,
gave me a
Chantal,
heart
you
attack.
ready? Sorry.
Yeah,
Okay,
okay,
let's
Chantal
hear
is
it,
here.
Chantal. There should be a pop-up to unmute. Sorry, I didn't click. There we go. There we go.
Ma'am.
Hi.
Hi, ma'am. So I said 5x. I put the like terms together.
Okay.
I said 5x to the power of 3 minus 2x to the power of 3.
Good.
Plus 3x to the power of 2 minus 8x to the power of 2.
Good.
Plus 7x minus 6x.
Excellent. Well done. So guys, exactly as Chantal said, group your like terms, or at least identify your like terms. Okay, Chantal, next one.
I said 5x to the power of 3 minus 2x to the power of 3 is equals to 3x to the power of 3.
Good. Well done.
And 3x to the power, positive 3x to the power of 2 minus 8x to the power of 2 is equals to negative 5x to the power of 2.
Good. Very importantly there, guys, it is a negative. Yeah.
And 7x, positive 7x minus 6x is equals to positive 1, positive x.
Good. So guys, like Chantal said, you can write positive 1x if you want, or you can leave it as just positive x. It's really up to you. But we've now simplified. Chantal, can we do anything else?
Oh man.
Are there any more like terms?
No, ma'am.
Exactly. So guys, no more like terms like Chantal says. We're done. Can't do anything else than that.
Well
Very,
done,
very nicely
Chantal.
explained, Chantal.
Nice.
Okay, guys, so exactly. Group your like terms, add and subtract them. That's it. Okay, nothing more complicated. If we can get like terms down, you will be a-okay. Right. I'm just going to do that. What I want you guys to now try is question B over here. I'm hoping that we remember how to do this from our last lessons. I'm not going to write anything down. What I am going to say is that, remember, a fraction can be separated. If you have got all of these terms in your numerator all over one denominator, you can separate your fraction into separate fractions to simplify. That's all I'm going to say. Try question B. Right, so again, my hint, you can separate the fraction. Good, keep those answers coming. Grade 8, you're doing so nicely. I just want you to know that I see, and Yolanda and I both see how hard you guys work, and we really appreciate it. And honestly, every lesson, as much as we sometimes fight, I'm so proud of you guys, and you guys should really be proud of yourselves for how much effort and how much time you spend doing your maths.
Yeah.
So you should be really proud, and we're really proud of you.
Yep. So proud, guys.
Ndlovu, is this a hand to answer?
Lovu, you may actually do your hand if you are writing tomorrow. Not that I'm excluding everyone who's not writing tomorrow, but preferably I'm just thinking that those that are writing tomorrow, please, you must take part of this in answering questions, okay? So Chantal already gave you a chance. I'm just not sure whether Ndlovu or Senzo or Luba is the one writing. We haven't even fought before. Teto, yeah, you are definitely new. That's why. So I just need, for those who their hands are up, just tell me if you are writing tomorrow. Is there any one of you writing tomorrow? I'm writing tomorrow. Bonolo, we are taking you. Guys, I know, sorry, we just prioritize because they're writing tomorrow and we want to help to see if they get stuck somewhere or if they know the work, okay? We love all of you. And remember, we can't take everyone's hand. Hi, Bonolo, you can go ahead.
Okay, ma'am. So firstly, I divided my terms. So I said 2a squared divided by 2 minus 6a cubed divided by 2
Good.
plus 4 divided by 2.
Excellent.
So ma'am, 2a squared divided by 2 is equals to 1a squared.
Good.
Minus 6a cubed divided by 2 equals to 3a cubed.
And is it positive or negative?
Positive.
Careful, a negative divided by a positive is?
Oh, a negative, ma'am.
Excellent, well done. So negative 3a cubed, good, keep going.
Plus 4 divided by 2, which gives me 2.
Excellent. Do you have any like terms here?
No, ma'am, we're gonna stop there because we have no like terms.
Wonderful. Excellent, Bonolo, well done. Okay, so guys, there you go. That was the hint I gave you, and Bonolo did that beautifully. Separate your fraction. If you've got no like terms in your numerator and you can't do anything in your numerator, separate the fraction. Okay, because then you can simplify each of them individually and you can get your final answer. Right, so I'm just going to make these two smaller in case you need to or miss taking screenshots. Oops. Right, we're going to do one more. You're going to try it. So there's your last one. You have got this. I'm not going to say anything. I'm going to let you try. Let's see what happens. So there's question C. Give it a go. Think carefully about what needs to happen first. So think about where you need to multiply first. You only deal with like terms at the end. So do any multiplication that you need to do first. That's my only hint. Zenzo, if you have a question, you're welcome to put it in the chat. Or even send Yolanda or myself a message. We're happy to help. And guys, just to be clear, these signs are multiplication. This is a variable x. Okay, so it's saying 3 times x times y. Maybe if we need to rewrite this, we can say minus 3 times x times y. So if you want to write it with brackets rather, that's fine. It's multiplication. Sorry, I just realized that we might get the x and the times confused. Keep those answers coming, guys. You're doing so nicely. So proud of you. Make me want to cry in a good way. Cry with pride. And Lovu, nice. Double check if you've got any like terms there. So guys, remember, once you've done your multiplication, always double check for like terms. There might not be, but sometimes they are, and we always need to simplify. Okay, grade 8. Very nice. All right, so let's have a look. What I first want to do is I first want to make sure we can see where our terms are. So this minus sign is separating my terms. So I've got 2 terms here. I've got 6 times the bracket and then that minus 3 times x times y. So I need to simplify my terms. In my first term, I can hopefully see that I need to distribute. So what I need to do is I need to take the 6 and multiply to xy and to the minus 2y squared. So 6 times xy is just 6xy. 6 times minus 2y squared, well, a positive times a negative is a negative. 6 times 2 is 12. And then we've got that y squared. So I've distributed my first term. In my second term, I'm just multiplying everything. So I'm saying minus 3 times x times y. And that gives me minus 3xy. Hopefully what I now see is that I've got some like terms here that I need to deal with. So here's a 6xy. Here's the minus 3xy. Those are like terms. The minus 12y squared is Jim all by himself, but that's okay. We're not going to exclude him. He'll just be at the end of our expression. So now I can write down my answer. 6xy minus 3xy is positive 3xy. And then I've got my minus 12y squared. No more like terms. So that is my expression simplified. Okay, very nice. So guys, just be careful. There were a lot of minus 3xy's. Just be careful. If we take those like terms 6xy minus 3xy, if you think of your number line, if you're at 6 and you're subtracting 3, you're not going to a negative value. You're still at positive 3. So that's why we've got a positive 3xy in our final answer. Okay, but on the right track, this was slightly harder because it looks a little bit weird.